Mr. Donahue, you ready to do 4?
Yeah.
Let's do it. What's secant?
1 over cosine x.
What's tangent?
Sine x over cosine.
Flip. All right, what happens?
It's still cosine x on top, right?
Yeah.
Oh, it's just cosine x sine x.
Yeah.
Okay.
Multiply straight across, right?
Yeah.
You can't cross multiply.
You can't cross multiply because
Well, like,
multiplication.
Okay, you get rid of the
Yes, you could, and you should, and you have to.
Okay.
So cosine x should be canceled out here, right? Because it's a factor in both of these.
Yeah.
Right? So if I look at it this way, I should know that I cancel those out. Right?
Sine x.
1 over sine x, which we could write as 1 over sine x, that's perfectly appropriate, or cosecant x. All right, Ms. Gathille's got a head start on the rest of you on problem number 5, but go ahead and try problem number 5. How can I do that?
Well, I thought about multiplying cosine on the bottom, like the whole expression by a negative, to get it to no, it's not right.
I gotta do it. Can't express all. Look, what can I add to cosine and sine and not change it? No. What can I add to an angle and not change what it is?
Okay.
360, or in the case of radians, what would it be?
2 pi.
So I could add 2 pi or subtract 2 pi from either one of those top or bottom, and I'm not changing a thing. What do you want to do?
2 pi.
Add 2 pi to what?
The bottom.
The bottom one. If I add 2 pi to the bottom one, what do I get? Huh. And now, Ms. Gathille, what can I do?
You can
And honestly, if you got this far, I'd accept this as an answer. But what can you do with tangent? It's not 2 pi we can add or subtract. What is it you can add or subtract from tangent? What's its period?
sorry.
Oh, last chapter. What?
Pi.
Pi, right? So I could subtract a pi, and I could actually get, this thing is actually tan of theta. That's it. Done. Sick and weird as that is. Yes, ma'am?
Could you explain one more time when you did the 2 pi? Like, why you did that?
Well, let's say this angle is 30 degrees, right? If I add 360, what happens?
Oh, it's the same.
Same thing, right? So I can, inside these parentheses, add 2 pi or add 360 if it's a degree thing anytime I want. It can't change the answer. Is that okay?
Yeah.
Now, again, this is the least important problem in this worksheet because we're not going to do this very often. Really. The next one, though, now we're starting to get to business. Let's get the next one. Everybody try 6. That's exactly, well, first step is to see if you can do some good algebra. If I got 4 things multiplied together, I have no way to multiply them together, right?
Yeah.
So I'm going to go ahead and just forget that and go right to sine and cosine. That's already a sine, so that's good. That's already cosine. Well, that's not too bad. What's secant?
1 over cosine theta.
1 over cosine theta. I love it. What's cotangent?
Cosine theta over sine.
Love that. Okay, now, you could stop and say 1 over tangent first and then do that sine over cosine, then flip it back up. It takes 2 steps to get to that same spot. It's worth remembering probably. That's cosine over sine. All right, so this is all things multiplied together, right?
Yeah.
So I've got a sine theta, a cosine theta, a cosine theta, and I got a cosine theta, and I got a sine theta. Anything I can cancel out?
Cosine theta and sine theta.
I got a sine theta I can cancel out, and a cosine theta I can cancel out. What's it behind?
Cosine theta.
Cosine theta. Okay.
Yeah, I
That would make that much harder. That's true. Okay, try number 7. Now listen to me. On 7, do good algebra as your first step. If you can do something that makes your life better algebraically, you should start there. Then change your sine and cosine, then just keep doing good algebra.
Cosecant theta minus cotangent theta plus cosine theta times cosecant theta.
Wait, what? First, outers. Oh, you did outers. Okay, inners. Okay, maybe I'm wrong. Okay, then inners, cosine theta, cosecant theta.
Yeah, and
Sorry.
then minus cosine theta cotangent theta.
Okay, I'm with you.
And then I converted that to like the sine and cosine. 1 over sine theta, yeah, minus cosine theta over sine theta plus cosine theta over sine theta. And then minus cosine squared theta over sine theta.
Woof, you went fast on that one.
Okay. And then
Pause. That was fast.
alright.
Because some people thought fractions are different than you're thinking. You're like went really fast through that step. Mr. Zion, you okay with that step? Donahue, you okay with this step?
I'm kind of confused.
Okay, so let me. I'm gonna take a moment to explain this step. Okay. All right. So I've got cosine theta. Cosecant's 1 over sine theta, correct?
Yeah.
Minus I got cosine theta times cosine theta over sine theta. Is that okay with you?
Yeah.
Okay. So then I got 1 over sine theta minus cosine theta over sine theta plus, now multiply straight across, right? With fractions?
Yeah.
So this is just cosine theta over sine theta
Okay.
minus cosine squared theta over sine theta. I think you're right on the money. Just you didn't get the last step.
Okay.
You don't erase nothing. You're right on the money, right there. Okay. Is that okay with you, sir? Mr. Donahue, you okay?
Yeah.
Okay, Mr. Cassini.
Yeah. Okay, then I saw that there's a negative cosine theta and a positive cosine theta over sine theta. So I just like cross those out. And then it's, yeah, 1 over sine theta minus cosine squared theta over sine theta. And they have the same denominator.
Okay, slow down. You got ahead of me. Okay, so 1 over sine theta minus cosine squared theta over sine theta, right?
Yeah. And
Since they have a common denominator.
Yeah. And then you can write it like that. And then 1 minus cosine theta, or cosine squared theta is sine squared theta.
Anytime you have a cosine squared, you can replace it with 1 minus sine squared, or 1 minus cosine squared simply is sine squared theta.
Yeah. And then, yeah, you simplify from there.
That's a real problem. But look, we're already doing it. Did I mess up? You see? I got to the same place you did. 1 minus cosine squared over sine squared, sine theta. And then 1 minus sine cosine squared is sine squared. Sine squared divided by sine is just sine. On. And a smiley face. Whoop. Thank you, Mr. Cassini. That was very well done. All right, we got problem number 8 to do. Sine x over 1 plus cosine x. Oh, I'm wrong. There's no way they could be right. Maybe it could be right. Hold on. I'm not. No, I'm starting to not like that your answers. I forgot about something. Yeah. Good, sir.
So I Did the cross multiply the tops?
It's all like finding a common denominator, right? I'm going to do this times this. And x times 1 plus cosine x all over. At the bottom, I got to FOIL it together, right?
Oh, you do?
Yeah, because I multiply this together.
Oh, okay.
So I end up with 1 plus cosine x times 1 minus cosine x. All right. What do you do at the top?
Do you make that sign squared? Or
How's what?
Isn't one? Oh, never mind. So it would just be sine. You
Right.
just distribute.
Yeah. So we got sine x minus sine x cosine x plus
Sine x plus sine x
plus sine x cosine x. On the bottom, what am I getting?
Limit.
Oh, waiting.
On the bottom you get 1. And then
Outers, so negative cosine x.
and then cosine x, cosine squared.
Yeah, I don't know.
You two are darn close, though. Darn close. Darn close.
And then can you cancel stuff out?
Yeah, let's cancel some stuff out. It's just a good algebra.
So the cosine.
You cancel out 2 cosines. I see something else I can cancel out.
There is.
I got a negative sine x cosine x and a positive sine x cosine x, don't I?
Yeah.
Those are the same thing, right? One's a plus, one's a minus.
Oh yeah.
Ka-ching, ka-ching. So what's sine x plus sine x?
Two sine x.
That's exactly what it is. Over 1 minus cosine squared x. Now, you might be thinking you're there at the end, but you're not, because you got a cosine squared and everything else is in terms of sine. How to get rid of that cosine squared?
Isn't that equal to sine squared x?
So 1 minus cosine squared is sine squared x.
Oh, I see.
Yeah?
Yeah. You go any farther?
I got sine x on top. I got sine squared on the bottom. Well, if I had 2x divided by x squared, can I go any farther?
Yeah.
What did you do?
I don't know.
You divide top and bottom by x, wouldn't you? Because this is like factors of 2x over x times x. I can cancel out an x and get 2 over x, right?
So it'd just be, you just divide by sine x.
Yeah, and I'll get 2 over sine x, which is correct. Or I'd accept 2 cosecant x. That would be fine too. Either one of those is perfectly fine, okay, happy, dory, hunky-dory, fun. All right. You guys wondering how hard the chapter is? We just got done with worksheet number 2. And the first one was review. Let's look at the next worksheet. Next worksheet says it's 6.3. It says verifications on it. There's no instructions, but the instructions should say the following. Verify each of the following. Verify each of the following. Now, by verify each of the following, what I'm saying is this. I'm saying you have to prove they're equal, which means you cannot